If the input size is large, then the time required to complete the execution is also increases. What is sorting? Sorting is nothing but the arranging the element either in ascending order or descending order. When I want average time complexity, then I'll go with the theta notation. Theta in the sense what? Average. Hello to all, a warm welcome to my new session on asymptotic notation. I am your Revati ma'am, faculty from the Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So dear student, before going to start my today's session, let me to recall the topic what I have discussed in my previous session. In my previous session, I started with what is algorithm. So what is algorithm? Algorithm is nothing but the finite number of steps used to solve the particular problem. So I am going to tell exactly that to complete the task or to complete the problem, how many steps I required, that is known as algorithm. Along with that, we also discussed the fundamental concepts of algorithms. Now, in my today's session, I am going to discuss asymptotic notation. This asymptotic notation plays a very important role in algorithm. So, what is asymptotic notation and what are the different types of asymptotic notation we have in our algorithm? I'm going to discuss all those things in my session. Okay, fine. What is asymptotic notation? It is a mathematical representation. Mathematically, I'm going to tell that, okay, what is my time complexity? What is my space complexity? So what is time complexity here? Time required to execute the algorithm. Okay, then what is the space complexity? Space occupied by the algorithm. That's nothing but the space complexity. So here, the time complexity plays a very important role. If the input size is small, for example, n value is 2, okay, what's going to happen? The execution time increases. In the sense what? How many iteration I'm going to have? Only 2. For example, if n value is 10, then the execution time is going to increase. Okay, fine. If n is nothing but the 100. Okay, based on the input size, the execution speed of the algorithm is also going to increase. Then, how I'm going to calculate time complexity in my algorithm? So, before going to start writing the program, okay, in my algorithm, I'm going to consider the frequency of the instruction. Frequency in the sense what? That's nothing but the repetition of an instruction. So based on the repetition of an instruction, I'm going to find the time complexity. So the efficiency of an algorithm is mainly depends on the amount of time required by the algorithm and storage space occupied by the algorithm as well as other computing resources. So, with the help of asymptotic notation, we can able to find the time complexity, storage complexity as well as other resources. So, an algorithm may not have same performance for the different type of inputs. So, if the input size is small, the execution speed of the algorithm is high. If the input size is large, then the time required to complete the execution is also increases. So, with the increase in the input size, the performance of the algorithm is going to change. So, asymptotic notations are nothing but the mathematical notation. So, mathematically, I am going to represent how much time I require to execute the algorithm, how much space I require to store the algorithm, that is represented in terms of mathematical notation. So it describes the running time of an algorithm. So what is algorithm? Algorithm is nothing but the set of. So what kind of set? It is a finite set of instruction used to solve the particular problem. So when the given input tends towards a particular value or limiting value. Okay, fine. If I consider the bubble sort, we are familiar with sorting, right? So what is sorting? Sorting is nothing but the arranging the element either in ascending order or descending order. Okay, fine. While entering input, if I enter all the input in the ascending order, okay, then what is my time efficiency? See, all the inputs are already sorted. So I don't want to sort the array element. Okay. So for example, in bubble sort, when the input array is already sorted, the time complexity is nothing but the best case. Okay, fine. When the input array is reverse condition, in the sense what? In the descending order, and I want to sort all the array element. For example, okay, my array elements are 4, 3, 2, 1. And I want to sort this array element in the ascending order. So what is the time complexity? That's the worst case, right? In the worst case, I'm going to have the descending order of an element. Okay, fine. If I consider the asymptotic notation, I'm going to have 3 majorly used asymptotic notation. That is big O notation. So it is big O notation. That is nothing but the worst case. So, okay, I'm going to consider the worst case of an execution time of an algorithm. That time it is big O. Okay, fine. Then if I consider average case, then it is theta notation. Theta is nothing but the average. Okay, fine. Then what about omega? That's nothing but the best case. So best case is nothing but the omega notation. Okay, fine. Let me to explain this concept. I'll take one small example. Think that, okay, I have the array element 4, 5, 2, 8, and 9. Okay, and I'm going to have the linear search. This is the example for linear search. At the beginning, okay, my key value is 4. First time, I'll consider key equal to 4. Okay, fine. What I will do? How the linear search algorithm is going to work? So it is going to search linearly. In the sense what? The key element is compared with all the elements of an array. If the key is found, what I will do? I'm going to display the position of an array. That is nothing but the position of the key element in the given array. Okay, fine. So what is key? Key is nothing but the 4. So I'll compare 4 equal to 4. It is true. Okay. So I'm displaying that key is found at the position 1. Okay, it's the first position, right? So it is 1. Okay, fine. Then what is the execution time? How much time this algorithm is going to take? Okay, the time occupied by the algorithm is here, that is best case. This is the best possibility, right? At the first position, if I get the element, then that is nothing but the best case. Okay, fine. Now let me to consider the worst case here. Okay, key equal to 9. What's my key value? It is 9. And if I see the array element where the 9 is present, 9 is present at the nth index. So it is my first, second, third element, fourth one, and fifth one. And if I consider the array index, index starts from 0 and it is n minus 1. So it is 4. So my key is present at the fifth position. That is 9 equal to 9. It is true, right? Fine. Now, what case this is? This is nothing but the worst case. At the end of the array, I'm going to get the key. So it is nothing but my worst case. Then what about average case? If the array element present between this array list, that's nothing but if the key element is present within this list or array, then it is called average. Okay, fine. I'll take key equal to 2. What's my key now? Key is 2. If I consider the array where the key is present at the third position. So it's nothing but the average case. So these are the 3 notations most commonly we use in our algorithm. That is nothing but the big O notation, omega notation, theta notation. How to write big O, omega, and it is theta. These are the symbols. Okay, fine. Now, what is big O notation? So when it is big O, you just want to remember that it's worst case. At the worst case, okay, what is my time complexity? Okay, fine. Big O notation represents the upper bound. In the sense what? The at most, maximum limit. Then nothing but the upper bound of the runtime of an algorithm. So it gives the worst case. What is my time complexity? That's nothing but the worst case. It is the most widely used notation and it specifies the upper bound. Okay, fine. The worst case time complexity and how to represent, that's nothing but the big O. Okay, fine. Now see here, I'm going to have the big O notation. What's my function? It is f of gn. So what's my function? It's f of gn. So to cross check, my f of gn must be always less than or equal to big O of gn. Now I'm replacing O with the constant value, that is c of gn. Over. Now, where n must be greater than or equal to k. This k must be greater than or equal to 1. Now, what is the value of k? That is, it must be greater than or equal to 1. And what about constant c? It also greater than or equal to 1. Now what I will do, I'll substitute f of n with the value, that is 2n square plus n. So n square is nothing but the quadratic equation and where n is nothing but the linear equation. Okay, fine. Now, I want to substitute the value in such a way that my f of n must be lesser than or equal to gn. So, I'll take f of n equal to c of gn. If I take c equal to 1, that's less than or equal to, if I take c equal to 1, see, I'm not going to get the true condition. And if I take 2 and substitute the value, here also the condition is not going to satisfy. So what I will do, I'll take the value c equal to 3. So what is c? C equal to 3 and randomly I'll take the value n is nothing but the 5. Now let me to substitute the value, that is 2 into n square is nothing but the 5 square plus n, that's nothing but the 5, which is less than or equal to, c is nothing but the 3 into, instead of writing n, I'll make it n square, so I'll write 5 square. If I take n, I'm not able to satisfy the condition, so instead of n, I'll take n square. I'll consider the quadratic equation. 2 into 5 square, that's nothing but the 25 into 2, it is 50 plus 5. This must be less than or equal to 3 into 25. So it is 75. Here it is 55. So 55 less than or equal to 75. So this condition satisfies. Okay, fine. So I want to choose C in such a way that must satisfy the given condition. Okay, fine. So we write f of gn, that is represented as big O of g of n. Okay, where n must be positive integer. That's nothing but the n must be greater than or equal to 1. Now I'll write f of gn must be lesser than or equal to c of gn. Okay, fine. Now I'm going to have the second possibility, that's nothing but the theta notation. So what is theta notation? That is average case. When I want average time complexity, then I'll go with the theta notation. Theta in the sense what? Average. Okay, fine. So in theta notation, the range lies between upper bound and lower bound. Okay, 1 is my lower bound and 5 is my upper bound. Then, okay, theta notation lies between middle. So it may be 3. Okay, so this is the running time of an algorithm. Theta is nothing but the average case. Okay, fine. Let me to consider example 1, 2, 3, 4 and 5. If the key is 3, key is present at the location 3. Okay, 3 is nothing but the average execution time, or this is the average time complexity. Now, see here, it is my upper bound, this is my lower bound, and Fn must lies between upper bound and lower bound. Then how to write? C1 less than or equal to g of n. Okay, this must be less than or equal to f of n, and m, that is n, must be, f of n must be less than or equal to c2 of gn. Over? Okay, fine. Now see here, we write the function initially. How I'm going to write? That is f of n, that is nothing but the theta of gn. And I'm going to have the n. N is nothing but the constant value. I'm going to select C1 and C2 in such a way that, okay, C1 must be less than the f of n and f of n must be less than the C2. So I'll write C1 of gn, which is less than or equal to fn, which is less than or equal to C2 of gn. This is nothing but the average time complexity. Now I'm going to have the big omega notation. So omega in the sense what? How to represent? Okay, this is omega notation. Okay, fine. When I use omega notation in the best case, okay, to represent best case, I'm going to use omega notation. So it is nothing but the best case time complexity. So here time complexity is pointing towards the lower bound. I want to select minimum limit. Okay, that is at least. So it's nothing but the lower bound. Okay, fine. See here, I'm going to have the function and my C of gn. In the sense what? So my function always greater than the C of gn. Let me to write that f of n must be greater than or equal to C of Gn. Before that, C is nothing but the omega of Gn, where C is nothing but the constant value which is greater than or equal to 1, n greater than or equal to 1, okay, that's nothing but the k is greater than or equal to 1. Okay, fine. Now, I want to select n value. So, what I will do, I'll consider the quadratic equation n square. Okay, fine. Now, I know f of n is nothing but the 2n square plus n. So, 2n square plus n, that should be greater than or equal to C of Gn. Now, I want to select C in such a way that, okay, f of n must be greater than C of Gn. So, I'll take C equal to 2, okay, and n equal to nothing but the 5. So, 2 into 5 square plus 5, that's greater than or equal to C is nothing but the 2 into 5 square. So, here n is nothing but the n square. So, 2 into 25, that is 50, plus 5, that must be greater than 2 into 25, that is nothing but the 50. So, 55 greater than 50. So, this is the way I can able to cross check. So, here C of Gn must be less than f of n. Okay, fine. So, how to represent? That is, see, C of Gn must be lesser than or equal to f of Gn. This one is also written as f of n greater than or equal to C of Gn, okay, where n is greater than or equal to 1. Okay, fine. In my today's class, I started with what is asymptotic notation. Asymptotic notation is nothing but the mathematical representation of an algorithm used to find the time complexity of a given algorithm. Which are the 3 asymptotic notation we have discussed? That is nothing but the big O in the sense what? Worst case. Then theta notation is nothing but the average case. Then I'm going to have the omega notation. Omega notation is nothing but the best case. If I get the element at the first position, then it is nothing but the best case. Anyway, dear student, let's meet in the next session with another interesting topic. Until that, keep watching and keep learning. Thank you.